Hi, I'm Anubhav from Nirmata, and today we're going to talk about virtual clusters. We know virtualization is a way to apply software defined segmentation, isolation, and management to virtual representations of physical resources, whether it is storage, servers, or networks. Now, as more organizations are adopting Kubernetes, they struggle with challenges like best practices enforcement, inefficient resource utilization, and cluster sprawl, and now they are starting to look at applying same virtualization technique to clusters. Now, what are virtual clusters? Virtual clusters deliver instant self-service environments to developers with zero-touch operations while ensuring operational control, efficient resource usage, and best practice compliance as defined by your central platform team. Virtual clusters improve resource utilization by packing multiple virtual clusters onto a single physical cluster. While virtual clusters are often used interchangeably with namespaces, the two concepts are not identical. Namespaces are the foundation for virtual clusters, but virtual clusters allow and require each cluster to be configured separately from each other, allowing access controls, security policies, network policies, and resource limits to be configured differently for each virtual cluster. The advantage of virtual cluster is that for users, they mostly appear and behave just like physical clusters. So what are the core components of a virtual cluster? We're going to look at six components. The first one being access control. This is to ensure there is centralized access management based on different roles within the organization. Second component is workload compliance to ensure that workloads being deployed are compliant with best practices as defined by the central governance team. The third component is network policy to ensure isolation between different virtual clusters. The fourth one is limits and quotas for your virtual cluster and your workloads. The fifth one is automated add-ons to ensure that your virtual clusters are pre-configured with the default set of services that the platform team wants to make available for these developers. And last but not the least is flexible access for developers, whether they would like to use CLI or a UI like Nirmata to create these virtual clusters. Now we're going to go into each of these components and see how we configure them in Nirmata. Access control for your virtual clusters can be configured through identity and access module in Nirmata. Along with authenticating users in Nirmata itself, Nirmata supports SAML and OIDC provider as authenticators for your team. Here we are configuring access for a user within a team for them to be able to create their own virtual clusters. It's important to note that they have to have NS creator permission, which can be granted by choosing environment create option. Now that we have configured access control, we will move on to configuring workload policies and network policy for compliance and virtual cluster isolation. Nirmata uses its own open source Kubernetes native policy management engine called Kyverno. Through Kyverno, you can configure different best practices rules for your workloads and your virtual cluster. Kyverno allows you to validate, mutate, and generate new resources in compliance with your best practices and standards. Through Kyverno, we will configure network policy that will be automatically pre-configured every time a new virtual cluster is created by the developer. Here is an example of a network policy that is configured for a default deny into that particular virtual cluster. Now you can very easily configure any permissions through simple allow and deny rules. As you can see, the policy is Kubernetes YAML compliant and pretty simple to write. Next, we will configure what type of virtual clusters developers can create. This can be configured with a set of environment types which define different sizes of virtual clusters, and a global IAM policy that defines which developers can have access to be able to create these virtual clusters. As you can see here, these resource quotas and environment types are configurable. And when you go to identity and access in your team configuration, you can see that you have ability to set up permissions for different environment types that will be available for the developers to create virtual clusters. Lastly, we look at what does a developer experience look like once a virtual cluster has been configured. So here I am logged in as one of the users that has been part of that team. And as you can see, I see only the clusters I've been given access to. I go in there, it's a read-only access. And when it comes to creating virtual clusters under environments, I see an option to create a cluster, right? And here, as I create the cluster and I pick an environment type, only the environment type that I have been allowed to create is of this particular size, right? And I can pick one of the two clusters that I have access to, and I can define the namespace if I want to be different from the name of the virtual cluster. I can do that, and there you go. Now I can, in this virtual cluster, deploy my apps, deploy configuration. This virtual cluster has been created with all the necessary services, network policies, and resource quotas that my platform team would like me to have. Now that we have created a virtual cluster through Nirmata UI, let us see what the experience looks like when we do it through CLI using NCTL utility. There you go. Now I can talk to the API. Let's see what kind of cluster access I have. I have access to prod demo. Now let's go ahead and create a virtual cluster on prod demo. As you can see, my credentials have been downloaded and an environment, a virtual cluster has been created for me. Let's see what the cluster looks like. I see environment test 6 is there. Now I can go ahead and deploy apps in this cluster using kubectl or NCTL utility. Thanks for watching this virtual cluster demo video. If you'd like to learn more about Nirmata, go to nirmata.com. If you'd like to take Nirmata for a test drive, go to try.nirmata.io. Or if you want to learn more about Kyverno, you can go to kyverno.io. Thank you for watching.